Hello everyone and welcome back. Today we will go for first problem of equilibrium. Now here in this problem for the member shown in the figure, so you can see that in figure bell crank lever B, A, C is given. Find the magnitude and direction of the reaction as hinged supported at point A. So here you can see that this bell crank lever is provided with a hinge support at point A. Solve the problem without using equations of equilibrium and neglect the weight of the member. Now we know that any problem of equilibrium can be solved either by equations of COE, I can say this conditions of equilibrium, okay, and second is by Lami's theorem. Here it is clearly mentioned that solve the problem without using equations of equilibrium. So I am not allowed to use conditions of equilibrium. Then I have to go with the Lami's theorem. So now let us try to draw free body diagram of the given member. So here you can see that first force acting on this member is over here. You can see that 30 Newton of downward force. Second, a hinge support is provided. So we know that for hinge support during our theory session, I have already explained you that for hinge support there are two reactions, because in hinge support we allow that body to rotate about the pin, so that moment is eliminated because in that direction motion is allowed. So what is left? We are restricting motion in x-axis and y-axis. So here we will show two reactions. One is HA, that is horizontal reaction at A, and next is VA, that is vertical reaction at A. Next is, you can see that at point B, that point B and B is tied with the help of the string. So here a rope support is provided. We know that in rope support tension acts parallel to the rope and it is always directed towards the fixed support or away from the body. So this will represent tension T. So right now we are facing problem with the Lami's theorem is that in Lami's theorem we can use Lami's theorem only when there are three concurrent forces. But here you can see that 1, 2, 3 and 4. There are 4 forces. So first what we have to do? We have to find resultant of this HA and VA. So what we'll do? We will combine this force and we will represent it as a single force. So let us say that that force shown over here is nothing but RA and it is making angle theta with horizontal. So now what we have done? We have found resultant of the HA and VA. We have combined that force and represented that as a single force RA which is acting at angle theta, so that now we have reduced a 4 force system body into a 1, 2 and 3 force system body. Next, if we extend this line of tension and this 30 Newton, so as you can see here it will form a rectangle, and then RA will represent a diagonal of that rectangle. So definitely if I'll extend the line of RA, it will pass through the next point. Let me call that point as a point D as shown over here. So it is passing through point D. So can I say that line of action of force, three forces, that is RA, 30 Newton and T, is meeting at one point D, and hence I can say that this given force is a concurrent force system. So in this diagram, can I show like this? Because I can show force anywhere along its line of action. So this will represent force T, this will represent force of 30 Newton, and this RA if I extend, then here you can see that I can show RA like this, which is making angle theta with a horizontal. And as you can see at point D, all the three forces are acting, that all forces are moving away from the point D, and it is represented as a concurrent force system. Now before moving to the Lami's theorem, very important task is to find this angle theta, because once I know angle theta, then only I can go for sine rule, or we can say Lami's theorem, because Lami's theorem is basically applying sine rule. Okay, so when I want to find this angle, what I'll do, when this angle is theta, I can say that even this angle is theta. So let us take this triangle, and that triangle is what? ADC. So if I redraw this triangle, A, this is D, and then this is C, then I can say that this is angle theta. What is this height? So this height, you can see here it is given as what? 3 meters. So I can show it as what? 3 meters. And what is this length? AC. So A to C, it is given to me as 4 meters. So I'll write 4 meter over here. Okay. Then if I want to find angle theta, can I say tan of theta is equal to opposite upon adjacent, that is 3 by 4. And this will give me theta is equal to tan inverse of 3 by 4, and on solving this I'll get answer of theta is what? 36.87 dt. After drawing this, we will go for second step, where using Lami's theorem we will find T and R. That is what we have to find. What we have to find? We have to find reaction at A, that is RA. So to find RA, we can apply now Lami's theorem. See, this sum can be solved by both the methods. I can get answer with equation of COE, or I can also get answer with Lami's theorem. But it is mentioned in the problem that you solve it without using equation of equilibrium. Hence I am going for Lami's theorem. And here you can understand that how a 4-force system can be reduced to 3-force system, so that I can apply Lami's theorem. Now considering this as a point D, and let me draw a diagram so that I can apply Lami's theorem. So very first thing is a downward force of 30 Newton. Next is horizontal tension T. So here I can see that this angle is what? 90 degree. You can clearly see this is vertically downward and this is horizontal. So angle made between these two forces is what? 90 degree. Next is RA, and that RA is making angle theta with horizontal. Okay. Now let me apply sine rule. So what is sine rule? A ratio of force upon sine of angle made by other two forces is constant. Okay, so let us understand. First I have considered a 30 Newton of force. So what I am considering? This 30 Newton of force. Then what is the angle made by forces other than this 30 Newton? So which forces are left? T and RA. So what is angle made by T and RA? So can I say this is an angle made by T and RA? Can I write this as, see, this total is 180. This angle is theta. So can I say that angle made by T and RA is 180 minus theta and sine of that angle? So sine of 180 minus theta. So that is first force. Let us go for a second force, that is tension T. So here I have written tension T. In denominator what will come? Sine of angle made by other two forces. Then what other two forces are left? 30 Newton and RA. So what is angle made by RA and 30 Newton? So is this total angle? Yes. Then this is given as 90. So can I say that it is 90 plus theta? So here I will write sine of 90 plus theta. Okay, and then finally I am going for last force, that is what? RA. Okay, what will come in denominator? So angle made by other two forces and sine as a function of that angle. So RA upon sine of angle made by T and 30, that is how much? 90. So sine of 90. Now here if I'll take first and second equation, I'll get answer of T. If I'll go for first and third equation, I'll get answer of RA, because I know value of theta, that is given to me as what? 36.87. So when I'll solve this, I'll get answer of T as 40 Newton and answer of RA as 50 Newton. So here I have solved this problem with the help of a Lami's theorem. We have got answer of magnitude and direction. When they are saying magnitude, so I have to find RA, and direction, so theta, because this is RA ka direction is theta. I have calculated theta, so I have got RA and theta. I have solved this with the help of a Lami's theorem. Now you try to solve this problem with the help of the equation of COE, and you must get same answer of T, RA and theta. I hope you have understood this sum. Thank you.